So someone is asking, will multi-platform be something that happens by default as you write code instead of consciously trying not to break compatibility? The answer is it will be the opposite of C. So in C, if you want to do anything interesting, you basically have to write a bunch of if-defs and platform code, right? Here it's the opposite. Right here, you'll be able to interface with audio and sound and anything just from the standard library without doing something platform specific. But you will maintain the ability to do things that are platform specific if you would like, right? But all this stuff that I've shown today, right, when we ship the compiler, part of shipping the compiler is making sure that all this stuff works on every platform. So it'll work. That's just what it means to have this language on all these platforms. It won't be that hard to make it work because all we're doing is making the bytecode run at compile time and runtime, right? And then porting a small amount of stuff. So you need OpenGL to work, or if your library has a different, say you're shipping on iOS. Well, iOS supports OpenGL, but maybe you want, Metal to work or something, right? Then we would provide some alternate code that has the equivalent of if-defs that hooks into Metal, but that would be at the library level. You wouldn't have to think about that as the application unless you then wanted to do something additionally low level. Wow, there's a lot of questions. Guys, I can't read all these questions. I'm just getting bombed. So I'm going to try to answer them in a random order. Let me see. So someone's asking, what kind of messages do you get for polymorphic procedures? You get the same messages as you do for every other procedure, right? The reason I don't instrument polymorphic procedures here is because they don't run. But then when they get, so for the original, let's go to a polymorphic procedure so I can get specific about this. Let's go into basic, right, array add. So here's a polymorphic procedure. It takes an array of any type and an item of the same type. We've talked about this before. So this, first of all, before anybody can use it, you will get a message saying this polymorphic procedure exists. Here's the body. If you want to modify that body, you can, actually. But I don't think it's a good idea because when you instantiate this for a given type, you'll also get messages for that specialized version of this procedure for any given type. And you might as well hook those and think about those, right? And you don't want to make the mistake of instrumenting things twice, right? You might accidentally put one profiler hook here and then another one when the instantiated one comes through, right? You'd actually put them on this, or in this order, because you're prepending. You don't want to do that. So I might as well just leave the polymorphic procedures untouched. But for some applications, you might want to touch them. So for example, the Go Bananas profiler stat thing that I showed last time, and at the beginning of this time, reported polymorphic procedures to you like everything else. And their specializations as well. So sometimes you want all that information, sometimes you don't. So you get to choose. Let me try it. Okay, I'm scrolling up in the chat. Will there be a CUDA OpenCL abstraction? Well, hopefully there's lots of stuff, right? Eventually. I'm not thinking about that now because I'm just defining the base language. If I ship the compiler with the product, can I hack it to use this language as an interpreted-ish language? I mean, sure, but you already get that, so I don't know what that would buy you. You already can plug into the compiler and do anything at user level. So I don't know why you would do anything less portable than that, although maybe there's a good reason. And if there is, maybe we would find a way to do that at high level. Will we be able to debug optimized code? Yes, I'm relatively unhappy with the way Visual Studio, for example, falls down when code is optimized. And I guess GDB and LLDB do as well. I don't think that that's very hard. Or even in places where it gets hard, I don't think it's very hard to supply an additional option which is mostly optimized, but don't make my code into scrambled eggs so I can't follow it, right? I think that's very important because the difference in performance between a debug build and a release build can be quite large. And for a big game, a debug build could be very slow and it can impact your workflow heavily. to try and run that all the time to trace down a problem. So I think it's very important to be able to debug optimized builds, and that will be a priority, yes. What happens if I make a mistake and it infinite loops? Right now you get a stack overflow in your user level code that's running in the compiler, because you'll keep recursing. That code that tries to instrument things will keep recursing. We probably could do some work to detect that and do something more user-friendly if that happened. But I don't know. We'll see if it's a problem in reality. Won't optimizations mess this up? E.g., function inlining seems like the instrumentation should be added after that rather than when the ass is generated. So you know if things are inlined or not. Well, in certain cases, you know if they're inlined or not. Like if a procedure is declared inline, you could choose not to instrument it by just noticing that it's declared inline and saying, okay, we're not going to do that. If things are inlined at the calling site, but not at the caller site, then you would not necessarily know. So the question is, do we then want to do something interesting to let you handle that more generally? I don't know. It's an interesting question. Yeah, we've got one comment about extra functionality. Excuse me. Wow. I just ate something weird. We've got a comment about added functionality that you might add. For example, not showing the values all the time, but only latching when they go over a certain magnitude. I agree, that would be great. Some other stuff that profiler does that I didn't talk about is it shows variance. Like in that line-by-line view, when things get hot, like they go white, it means that that's a procedure with a lot of variance in its runtime from frame to frame, for example. But yeah, you can just go crazy and add arbitrary amounts of cool stuff. It's very easy to do because you're just programming code like you normally would write. So you just write whatever and go crazy. Can I attach notes to statements, expressions, blocks? Yeah, by adding those to the syntax tree, just like we did that other stuff. Oh, wait. Although, if you're asking, do they get attached at that level of expressions? Actually, no. There aren't note slots on expressions, if only because I didn't want to waste that much memory. That might be a wrong decision. For now, they're all at the declaration level. So we'll see. It's relatively easy to move them around and put them at expression level if we think that'll be useful. But I just, I haven't even used them that much yet. So I haven't run into a limiting case where I think, oh, I really want this on expressions. But yeah, we'll see. Someone's asking, couldn't I spare the strange compile time exec stuff by just having an interpreted mode for the compiler and letting it link and call the compiler's library? No, that's terrible. No, it's not strange stuff. The entire reason that we do stuff at compile time, and I've said this before, but I'm going to say it again because it's very important. The entire reason we do things this way is because all our compile time code runs completely in a well-specified language. You don't need build tools or products that are going to be different on different operating systems. You don't have to go insane and pull your hair out if you're trying to build and run code on 12 different operating systems and operating system versions, right? Forget all that, right? You run the compiler. It runs a well-specified language that runs everywhere. So all this build code that you run runs perfectly everywhere. It's a very powerful way to do things. So I don't agree. It may be strange in that most languages don't work this way, but I actually think if you look at languages, they're starting to creep toward working this way, just not very well, right? So like C++ is expanding the scope of, or scope is a confusing word to use when you're talking about languages, but it's expanding the breadth of what it lets you do in a const expr at C++, which is sort of the thing that could run at compile time. D gives you more latitude about what you can run, but it's not really intended to run full bore programs like this. Here we just say whatever, just go. I believe that many programming languages will be doing this 5 or 10 years from now because it's so powerful and so amazing. It gets rid of so many problems that you have otherwise. It's the obvious right, or it's one obvious right thing to do. I don't think it's the only way you could structure your language, but it's amazing when you do it. I mean, I'm able to do all this high-level stuff really fast, right? And it's because I'm not being slowed down by having to interface between different things. Everything is in one place, and everything can talk to everything else through the same language. It's great. It's like you have no problems. Like, it's the good part of what all the Lisp machine people would tell you was great about Lisp back in the day. There's a lot of things that were horrible about Lisp back in the day, and even still today, they don't talk so much about those because of whatever, selective blindness or cognitive capture or something. But it's an attempt to take a lot of the good things about that kind of environment and bring them to a modern day in a statically type-checked, very robust, and very low-level and fast language. So we're high level and low level. I've said that, but I'll say it again because it's worth repeating. Okay, those are older questions. Now I'm scrolling down to the bottom questions. Is it possible to copy, serialize whole abstract syntax trees from the compiler, then take that tree and compile it at a later time with modifications? Absolutely, you can do that. In fact, it would be a straightforward modification of what I did today. Someone's asking for a language spec doc. Right now, the language is changing quickly, so writing a spec would be a little silly. At some point, I want to do that, but we've still got some major features. The ability to modify code was one major feature that I wanted to get in. Sort of the last major one is struct polymorphism, the ability to, because this kind of polymorphism that we've done is only on procedures. We haven't done it for data structures yet. So we have to do that, and we have to make it work beautifully and nicely together between procedures and data structures. And then there's a few other things we want to do, like just basic language features. Like I said, we don't have array literals. We don't have a switch statement. I always write if this, if that all the time. So writing a language spec document before you have that stuff is not that great of an idea. But once we have this stuff, then maybe I'll write a tutorial or something and put the source out there. Do I think this language can be good for novice programmers to learn good low-level programming practices? I think so. I'm trying to make it as easy to get stuff on the screen as possible because, so I was watching, it was either Sean or Fabian who said this on the Handmade Dev show the other day, but they were talking about how we learned on BASIC and it was a horrible language. I think Fabian said this, right? And it's true that we learned on BASIC, and BASIC's a horrible language, but there was a very nice thing about it too, which is that it was very responsive and very immediate. You just type stuff and hit enter and it happens, right? And that's something that's kind of lost in all these complications that we have today. So I want to get back to that, right? You don't have to set a weird environment up and all these programs talking to other programs to get anything going. You just can start running. We'll have a read-eval print loop for the compiler. In fact, that's trivial to put together at user level. Yeah, I don't know. It'll be good. Any plans to make working with SIMD more intuitive? Yes, we're going to have intrinsics at least, possibly inline assembly before too long. But again, those are lower level priority than the stuff I'm doing now. I'm scrolling up in the chat. Someone's asking, have I talked to a lot of game developers about their C++ Visual C grievances? Oh, all the time. Believe me, We all have a lot of complaints about both C++ and Visual C++, and nobody in charge of either of those things seems to care very much. There's now actually a committee that's meeting this year about games in C++, but I don't have any hope that it'll do anything very good. No offense to the people on that committee. It's just that I personally, and many people I know, are fed up with C++. It's just a giant mess. Wow, this headset looks really goofy. I really want to get something smaller. Someone's saying they had a little bit of a hard time understanding what was part of the standard library and what was custom. Yeah, I mean, if you download the source, it'll make more sense because the files are in different places. I did zoom through a lot of stuff pretty quickly today. So, but yeah, hopefully this will be clear on YouTube. Hopefully I'll be able to upload the recording. I hope I'm not running out of space. Nope. Well, let me refresh that. Yeah. So hopefully this recording will be stored successfully locally, and I can upload a higher quality version. We'll see. More questions. Can I profile compilation with the same code? Yeah, I mean, I demoed profiling compilation essentially last time, where I showed, you can time when you get specific messages, and by that know how long particular files are taking, for example. And that gets a little more involved when you're compiling in parallel, but it's definitely doable. Do I plan to release a partial tool chain so people can use it for testing and experimentation? I will do that at some point. I want to get the basics of the language defined, and then I'm going to start releasing it to an ever-widening circle of people. So it'll be a small number of people at first, so that we can run into any like does the compiler crash in dumb ways if you look at it slightly in a way different from how I do, right? Etc. So we don't waste people's time. We'll do it on a small number of people, and then a larger number of people, and then eventually we'll release it to everybody in the world, but steps at a time. I don't want to. I want to be very efficient about not wasting people's time, basically. What was the first use of bake values that I tweeted about? Oh yeah, where was that? It was cool. I forget which file it was in. Was it in iProf? Yeah, okay. So, remember how I said you can flip through sorting your display in different ways. So, we have this enum for what are the different ways that you're sorting? By the self time, which is just the time in that one procedure, by the hierarchical time, which is the procedure in everybody who it calls, or by the count, or a call graph mode, which is what happens when you start navigating around. Okay? We wanted to call different sort routines, right, that sort in different ways. And how do you do that? Well, you could handwrite different routines. And in fact, for call graph, I left it as separate code because this is a light translation of Sean's code, and that's how he did it. So for call graph, it's got a separate routine, but for these three, we handle it all in the same routine. What we do is we have this function called compare slot that just takes the index of which value, right? So we're baking that for slot 0 or slot 1 if it's hierarchical time, or slot 2 if it's call count, right? So we compile 3 different versions of this sort function at compile time based on which one we want. Then, so this costs nothing at runtime, or I mean the if statement of assigning to the function pointer, but the bake all happens at compile time, right? And then we get down here and we call quicksort with this compare function, which is whichever of these, right? So let's look at this, pop compare slot. So just like any sort function, you give it two things to sort by. Unlike many sort functions in C, this is strongly typed because our quicksort is polymorphic, right? So we tell it it knows the types of what the things are by what procedure we give it, right? So now when we bake it, we essentially bake out this slot thing. So by the time quicksort gets it, it just gets a thing with two arguments. But, whoops. If this is confusing, you can look at what I have a whole demo where I demoed polymorphism and baking. That's on YouTube. Anyway, so you bake this slot in, and then that becomes a constant in here, right? So this just dereferences different slots and sorts by those slots. So rather than having to do something weird with like setting a global pointer, which would not be thread safe, I can pre-bake different versions of this procedure, right? So that's great because in C or C++, usually to avoid some kind of weird template hell, I would have done something where I like set a global about which slot and then called the same code, or I would have hard-coded the code in 3 different ways with like a macro. But this was beautiful because I just wrote it once, and then I said, okay, we compile it 3 times with different arguments, right? So it's almost like a JIT, but it's like a compile time. It's not just in time. It's way ahead of time compilation. I love doing that. It was great. Someone's asking if I've checked out dependent types. All that stuff, I don't know. I mean, I'll look at it, but it looks to me like a lot of complication for very little benefit. Both complication for the programmer working from day to day and in the compiler and in transparency of understanding what the compiler is doing, which is very important. So I'm not going to guarantee that any kind of dependent type woo-woo stuff gets into this language. Would it make sense to load user compile time code into a child process? That way, if it faults, you can debug it. Yeah, so in general, so right now, when I fire up like 4 different workspaces running different code, all of those, you could fire up 99 workspaces or 1,000 workspaces running different code in them, and eventually you're going to have a bug, right? And hopefully we will have a good debugger that runs at compile time. That'll get worked out somehow. But those processes are running the same programming language, right? Which involves access to pointers and anything. So you could step on the memory of a different thread or of the compiler, right? So to minimize confusion in that kind of case, you eventually want all that stuff to be strongly sandboxed from each other and from the compiler, right? So that you can't crash the compiler. You could only crash that one workspace or whatever. And that's definitely some way that you want to harden things once this gets released out into the public. And that's a plan in that I haven't thought about how to do it. It's just on the roadmap for the future. But yes, I think that's a very good idea. Is the build process deterministic? No randomness, no issues with the file name ordering from the OS, etc. Yes, you can do completely reversible builds. If that ever happens that you can't, it's a bug. Now, you also, however, will want to be able to turn on parallelism because as we get more and more cores on our PCs, compiling things in parallel lets you go a lot faster. So then it becomes a little bit of an application level question of whether you introduce irreducibility in your build because things are coming in different orders to you. Like the way that I profiled things, I just assigned zone indices to things based on what order they came in. I incremented a constant counter. So if that's automatically a race condition kind of thing where I'm going to get different numbers every time. So that will introduce a irreproducible build, but that's my fault at user level, right? Instead of assigning that index as things come in, right, I could actually assign the index in some way based on the name. It could be a hash that you look up, but that would be slower, right? I could wait until later in the compilation process and sort things by alphabetically, right? There's a number of things you can do to serialize that more. You could say, okay, look, if you're profiling we're doing a serial compile, not a parallel compile. But in principle, the core of the compiler is totally deterministic, and then anything that you do on top of it, it's up to you whether you introduce a non-deterministicness. But it's also up to us as compiler authors to make sure that you can do all kinds of great stuff without worrying about reproducibility that much. Okay. I'm running out of voice here, and I'm getting tired, so let's do one or two more questions. Will the language have non-null guarantees or optional types? I want to experiment with that a little bit. I'm not totally sold on it. I'm not sure it's as great as people think it is, but I want to at least implement it as an extension, like as an optional thing, and we can see how it is and see whether it's worth codifying for real. Oh, did I mention the limitations of doing this at this stage rather than only after parsing? Thank you for reminding me. So the limitation is basically that anything that reaches this stage has to be a correct program, right? So you can't sort of like write wild syntax that's weird. You can't write things that won't type check. So you can't like add arguments to a procedure and well, let me put it this way. There's dependencies in things in the compiler, and so you don't want to modify things and change their types, or else you'll generate an inconsistent program. Because we're hooking the stuff after it's past type checking, which means people who depend on that type checking could go past. There's ways of working around that. Let me just give you an example. If you've got a procedure with one argument, right, and I want to add an argument, which I didn't do today because in the way that the functionality that I've built so far doesn't do that. If you want to add an argument, you're changing the type of the procedure, which means that everybody who calls that procedure has to have not been type checked yet, or has to get re-type checked based on the modification you made, which means either you have to bottleneck compilation, which maybe will slow things down, or you have to have this dependency thing where you recursively invalidate everybody later, both of which could happen, and I'm not sure which way is better, but I didn't want to introduce that yet because this was already enough to show, right, for now. I do think it's important to be able to do stuff like add arguments to procedures. So one thing I was saying in the PowerPoint was that maybe you do that at this stage, right, which is an earlier stage, so that you haven't done that type checking on things. So you don't have to do all this recursive invalidation later down the pipe. You instead catch it early at a different facility. And so maybe the trade-off is, hey, we're still compiling really fast. We don't have to invalidate stuff. But when you're adding arguments to your procedure, maybe you don't know what the types of the things in that procedure body are yet, which maybe makes sense anyway because you might be changing that based on the modification you're doing here. So that was all I was saying, is there's a certain class of things that you want to do here, but there's a certain class of things that you want to strongly type check. So a production quality hardened release version of that profiler that I demoed will check to make sure when it's overriding swap buffers that it's really replacing GL swap buffers and not just some other thing that happens to be swap buffer. Like maybe you've got a networking code and you're swapping buffers for some reason because you're double buffering the network, like I'm filling versus transmitting, and you don't want to replace that swap buffers, right? So you want to be careful about that stuff, and the way that you're careful about it is knowing what those names resolve to, which happens later in the compile pipe. Now, whether any of this is the best way to do what I've demoed, or whether there's an altogether better way of hooking later in the pipe or somewhere, remains to be seen. But for now, I just wanted to get the functionality in there and demo it because it's amazingly powerful and I love it, and I just wanted to have it. And in my experience, the way to learn how things should work the best is to try an initial version and just see how it goes. Like rather than theorizing too much about what's going to work, just do something and try it and see how it works, but then be willing to throw it all away if necessary, right, and do the better thing. So That's the way I like to work. I think this is working pretty great so far, but we're going to have to see as more and more code gets added to the language whether it works well really or whether it's got certain problems. And so if it has certain problems, we'll either add additional functionalities like this one or add different stuff later in the pipeline. Just for clarity, I realized I didn't say this. So again, the substitution we were doing is this one. This would be more like a Lisp macro kind of a thing. All right, I think that might be it. I've spoken a lot today. I guess we'll take other questions later. Oh God, there's more questions. Is the for syntax set in stone? No syntax is set in stone. All of the syntax here can and probably will change. However, I like the for syntax, honestly. It's my favorite thing almost about... No, the compile time execution is my favorite thing, but for is good. So I don't know why you would want to change it, honestly. Do I envision this feature to be used in both debug and release? If you mean the profiling, sure, why not? It's more useful in release because release is closer to what you're going to ship. But you might use it in debug to say, like, why the hell is my program so slow in debug? I want to run in debug, but it's painful. Why? Could the profiler be used for unit testing? Sure. Thanks, everybody. Goodbye. Thanks for sticking with me for like 2 hours. That's hardcore. I'm going to hope to have another stream before too long with... Maybe polymorphism will be next time of structs, or maybe I'll take a break from big things and do a lot of like nicer little things. We'll see. How many people stuck through it till the end? There was like 500 and something people at the beginning. We got 300 stuck to the end of Q&A. That's awesome. Thanks everybody for being so interested in this stuff. It's very gratifying that people are, and I'm gonna. Like I said, now that the game is done, I have time to work on this. Of course, we're going to do another game, but that's in the early stages, and that means I'll have some spare time to work on stuff like this. And I'm even going to look for somebody to help work on it, which can help accelerate development. So thanks, and we'll have another stream soon. Goodbye.